For decades, configuring a router meant typing commands one line at a time into a text console, exact syntax, exact spelling, no room for a mistake to go unnoticed. One misplaced character in that type stream, the wrong interface name, a stray digit in a VLAN number, can take down real traffic instantly, with no warning. NETCONF and Yang replace typed text with something fundamentally different: structured data describing exactly the setting you want, in a form software can check before it ever applies. Every router publishes a Yang model, a strict schema listing every setting it actually supports, and every valid value each one can take. Those individual settings all live inside one config tree, a single structured representation of the device's entire configuration, not scattered command fragments. Structured data travels to the router over a NETCONF session, a reliable, machine-friendly protocol built specifically for exchanging configuration, not for a human typing at a prompt. Before anything real changes, the proposed configuration gets staged as a candidate, a draft the router can validate completely and reject cleanly without ever touching live traffic. Only a candidate that passes every check ever becomes the router's real running configuration. Let's follow one structured change from data to committed config in slow motion. Take one the old way. An admin needs to move an interface onto VLAN 20, so they type the command directly at the router's console, character by character. A single typo, VLAN 200 instead of 20, is syntactically valid, so the router accepts it without complaint. The mistake surfaces only once traffic starts misbehaving. Take two the modern way. The same intent, this interface belongs on VLAN 20, gets expressed as structured data, an explicit field, an explicit value, no typed syntax to get subtly wrong. That data gets checked against the router's Yang model immediately. Does a VLAN field exist? Is 20 a valid value? Is this interface even allowed to carry a VLAN assignment at all? Every one of those checks passes, so the change fits cleanly into the device's config tree, the single structured document representing this router's entire configuration. That validated piece of the tree travels to the router over an active NETCONF session, a persistent, structured connection opened specifically for configuration exchange. Rather than applying instantly, the change is staged as a candidate configuration, a draft sitting alongside the real one, fully formed but not yet active. The router now validates that entire candidate as a whole, not just this one field in isolation, but whether it conflicts with anything else already configured on the device. Suppose the candidate passes every check cleanly, no conflicting rule, no missing dependency. The router commits it, and the candidate becomes the new running configuration. Now suppose instead the candidate conflicts with an existing rule elsewhere on the device, something a typed command applied instantly would never have caught in advance. The router rejects the whole candidate and rolls back cleanly. The running configuration never changes at all, and no traffic is ever affected by the attempt. Compare that to the typed command world. A bad interactive command applies the instant it's entered, and only a second corrective command can undo the damage after traffic has already broken. The exact same structured data, sent over the exact same NETCONF session, works identically whether it targets one router or is replayed automatically across 100 of them. Yang is the modeling language that defines what data looks like, its fields, types, and valid ranges, while NETCONF is the protocol that actually carries that data to and from the device. This combination is what makes real network automation practical. Software can generate, validate, and push configuration changes without ever needing to understand one vendor's specific command syntax. Beyond validating single changes, NETCONF also supports reading a device's entire current configuration back out as the same structured data, useful for auditing exactly what's really running. The honest trade-off is setup cost. Every device needs an accurate Yang model and NETCONF support before any of this works, and older hardware sometimes only speaks the traditional typed command line at all. A typed command risks one silent typo becoming an outage, Structured data checked against a Yang model, carried over NETCONF, staged as a candidate and validated before it commits, never gets that chance. That's how it runs. Next time a network team pushes a configuration change to 100 routers at once with total confidence, you'll know NETCONF and Yang validated it first. Check out our other videos and follow how it all runs for more. See you in the next one.